We're going to be factoring difference of squares here. And so here's how we determine if something is a difference of squares. First of all, the word difference means that it's going to have this subtraction sign, and then of squares, so meaning that the first term is squared and the second term is squared. So if you can write some binomial means two terms, as x squared minus y squared. Anyway, and maybe it may be helpful to say if you can write it as something squared minus something squared. Okay, if I can write it as something squared minus something squared, then that means that is going to be a difference of squares, and you can simply factor that to just being x plus y and x minus y. Basically, whatever your x and your y is here, it just simply becomes that. So this is just the format. This is how you know if you have a difference of squares. So let's go right here. Let's see. Can we write our first term right here as something squared minus something squared? Well, yeah, right. I mean, we can write p squared as just p right here, and then what squared is 100? Well, 10. So we can write the first term as something squared, and we can write the second term as something squared, and we have a minus sign. So since all those are true, then again the answer is just x plus y, x minus y, or the answer here is x plus 10 and x, or p in this case, minus 10. Now, if you're like, I don't know about that, dude. Well, what you can do is just go ahead and multiply these through. Okay, you could just multiply through it, and then you're done there. All right, well, let's check out this guy. First of all, if it does have a common factor, I want to go ahead and bring that out. So I noticed that both of these guys have a 2 in common. So I'm going to first factor out that 2. And let's see what goes back inside. We'll have an x squared and then a minus 9. Okay, so the first thing I did there was just factor out the GCF. Now let's deal with just now what's inside of the parentheses. And notice that I can write the first term as something squared, and I can write the second term as something squared. And that something happens to be x, and that something here happens to be 3. Okay, so that's what you want. You want to write it as something squared minus something squared. So since we can write this as x squared minus 3 squared, then the answer is just x plus 3 and x minus 3. Okay, and you can verify these answers by multiplying these out, and you'd get back the original problem. All right, coming over here now, 9x squared minus 16b squared. Let's see, 9 and 16 do not have anything in common. So let's just see if we can write the first term and the second term as a squared. So let's see, what squared is 9a squared? Well, that would be 3a. I square the 3, I get 9. I square the a, and I get a squared. Let's see, I square 4 and then b, and that gives me 16b squared. So since this happens to fall in this pattern, then the answer is just 3a plus 4b and 3a minus 4b. And that would be it.